Hello and welcome to day 13 of Advent of Code, and today's task is point of incidence, whatever that means. Let's find out. So, with your help, the hot springs team located an appropriate spring which launches you neatly and precisely up to the edge of Lava Island. Okay. You don't see any lava. The valley between them is completely full of large mirrors. Most of the mirrors seem to be aligned in a consistent way. Perhaps you should head in that direction. As you move through the valley of mirrors, you find that several of them have fallen from the large metal frames, keeping them in place. The mirrors are extremely flat and shiny, and many of the fallen mirrors have lodged into the ash at strange angles. Because the terrain is all one color, it's hard to tell where it's safe to walk or where you're about to run into a mirror. You no doubt the patterns of ash and rocks that you see as you walk, your puzzle input. Perhaps by carefully analyzing these patterns you can figure out where the mirrors are. For example, something. To find the reflection in each pattern, you need to find a perfect reflection across either a horizontal line between two rows or across a vertical line between two columns. In the first pattern, the reflection is across a vertical line between two columns. So this part is the reflection of this part. Okay. Here. In this pattern, the line of reflection is the vertical line between columns 5 and 6. Okay. Because the vertical line is not perfectly in the middle, part of the pattern has nowhere to reflect onto and can be ignored. Every other column has a reflected column within the pattern and must match exactly. Okay. 2 matches 9, 3 matches 8, 4 matches 7. Yeah. The second pattern reflects across a horizontal line instead. Okay. This pattern reflects across the horizontal line between rows 4 and 5. Yeah. Okay. The remaining rows match. Okay. To summarize your pattern nodes, add up the number of columns to the left. It's 7 in this case. To that, also add 100 multiplied by the number of rows above each horizontal line of reflection. Aha! So you add up the number of columns to the left of each vertical line of reflection. So if this were reflection line, I would have to add 3 plus 7. Okay. To that, also add 100 multiplied by the number of rows above each horizontal line of reflection. Okay. Okay. In the above example, the first pattern's vertical line has 5 columns to its left, and the second pattern's horizontal line has 4 rows above it, a total of 405. Find the line of reflection in each of the patterns in your nodes. What number do you get after summarizing all of your nodes? Okay, so okay, so I have to parse chunks like this, and then I have to find all reflections. There are no horizontal reflections here because this line does not correspond to this line. Okay, but what happens if you have more than one horizontal reflection or vertical reflection? Do you have to sum them up? Interesting. Okay. Okay, let's just start. Yeah, let's get the example. What's the day today? 13. Okay. Let's save it. Let's also get the input. Okay. And then I have to get the answer. Okay, so let's get started. I hope this will be a super quick setup. Okay, now it works. Let's start. So, first of all, I have to get the arguments and do all this usual thing. I'm inclined to say yes, but do I really have to do that? Okay, let's just do it. Write file, have path. Let's print solve1 input as usual. Okay, yeah, so parse. Let's take a string and let's output let's say lots of patterns of characters. I don't really want to complicate that. So input, it's undefined for now. Solve1 takes a list of characters and also produces an integer or an int, doesn't matter at the moment. Patterns. Okay. Let's come up with the name later. So let's also import getArgs. And now let's parse. So first of all, it's still undefined. Where? So the lines. I can split the input into lines and then oh, I'm not running a Tmax. Okay. Okay. Then, how do I split by specific elements? So let's import list and let's look at it. Do I have anything that can split? Split at, break, okay. So there is no easy splitting. Okay, I will have to split it myself. And in that case, let's say that I want to use data list as usual. Let's say that maybe let's play here and then let's see how it goes. So let's read the input. Input is like this. I can get the lines of input and I can redefine it. Oh, it's a recursive definition, so no, it's not possible to do that. So okay, how do I do that? Okay, that looks good enough. Yeah, that's how I can debug it quickly. Yeah. Okay, that it is what I need. Okay, now let's first of all, let's try to break it on a line which is equal to an empty line. Or I could say that, oh, that it's null. That's it, yeah. So let's do it. And now let's do debug. Yeah, how does it even work? Oh, yes, monad trickery. So if you have a tuple of two elements, you can actually think of it as a monad of I'm not sure exactly what, but it's possible. Yeah, you just basically you just get the second element for some reason. I don't know why. What is this weird monad? But yeah, map mprint does not do what I wanted it to do. It's not a list directly. Okay. Now I want to. When I broke these lines, I want to unfolder the list starting from the lines of input and given an inp, I have to match it. What does lbreak do when there is nothing to break? Yeah, just it on the empty second sequence. Okay. So now let's do unfolder in or just s. Why not? And in case that s is maybe better to write it this way. If there are no elements in S, then nothing else. Just lbreak. Is it by null? The sequence. The sequence. Yeah. Wow! What was that? Okay, I really need to drop the first line in that. So I split it into a part, pattern, and I split it into the second S, which also must have a prepended empty line. And then I continue with okay, yeah. If null is, then nothing else, just b tail. Actually, I could pattern match, but yeah, it's not like I really want to go there now. So what do I get now? I get just one pattern. Why? 1, 2, 3, 4, 5, 6, 7. Oh, it just ignores everything else. Okay, why? So I have the line of input, and I use unfolder from that. Lines, 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 lines. Okay, well, why does it just ignore the rest? So I get this pattern, and I get this lens prime, and I do get the tail of oh yes, it must be the tail of but what's wrong then? Oh, now I get it. Yeah, it's the wrong order of checking. So if null lens, then nothing. Okay, and now the tail is obviously not what I want. Okay, good. Let's just pattern match that quickly. So case break no of if null lines, then what do I do? In this case, it's nothing else. I have to just break, but I also have to drop the first part of the second element of the tuple. Let p lines prime list break by null lines in yeah, I think I can just ignore it. I don't care about this. P lines. Variable not in scope NLS, which is here. Could not match the expected type in, yes, you're right, in just this. Exception, non-exhaustive pattern. Why? Ah, because it tried to break it, but didn't get anything, so okay. So I need a kind of a safe tail. And this safe tail can be what? Oh, that's how I avoid it. Okay. And I don't have to destructure it here. Okay, now what's on? Yeah, it's still just. And now I do have two different patterns. Let's write it down. Split by predicate sequence. I say that I unfolder. I have this as, if null s, then nothing else. I try to split it into a say x and the rest of the sequence by break on the predicate applied to the sequence in just ps prime. Okay, now where do I get rid of the leading line? Okay, here, tail. Oh yeah, I would be better off just using the split library from package. So, now I have my split. I can split by non-null, and I can split in the lines of input. Is this it? Use L, yeah, definitely. It's not unfolded, it's unfolder. Let's reload. What's on now? Can't match type string to bool of the predicate, right? Yeah, definitely here it must be x. Let's reload. Yeah, there is a variable shadowing. Let's call that sequence 0. So yeah, now I have written my own split by, and we can proceed. So if I parse with file example.txt, I do get two patterns. Perfect. Now let's solve it. So what do I get? I get a lot of patterns, and for each of them I have to count all of the lines, all of the reflections, both vertical and horizontal. So there is a very useful thing in Haskell called L.transpose, which takes a list of lists and flips it across the diagonal. This becomes this, and actually I can actually use it to look for, to transform my patterns before looking for reflections. For now, let's just look at the horizontal reflections, and then I can use transpose, and that will give me my vertical reflections. Okay, so let's do it. Should I call it count reflections? Or find reflections? Yeah, that sounds pretty good. So I have a pattern, and I have to produce a list of positions of these patterns. So find reflections in the field description. So what do I call it? Oh, I'm lazy. Let's call it input. Let's say int undefined for now. Where? Now let's think. Should I just try every possible horizontal line and see if it's really reflected? One thing that I'd like to do is to pre-process it to make it faster, but should I actually do that in this case? I'm not sure I have to bother with this. Okay. So let's ask the question: is a reflection should I try to do that as a zipper? So I have my inp. No, I don't have it. Okay. So, and I have a couple of patterns, and pattern 1, pattern 2. Let's say this equal to input. Is just a warning. Pattern 1, pattern 2. So, how do I iterate over that? What I want to have is a structure which uses two lists, and just basically at this point the first list consists of this thing, of this line, and the second list consists of all of these lines. And then I can actually compare them, and then I can say that this is a reflection or not. And then I can just move this line to the second list, and on the next iteration I compare this line to this line, and this line to this line, and so on and so on. Oh, that is actually pretty neat. So I start with up, down, and I say that if so actually I just have to use list iterate, right? Or will it be unfolder again? Okay. I'm just starting to... It's so funny how unfolder is so useful in so many situations. But yeah, so what do I have? I have pattern 1, and I want to unfolder it. And at each step, so basically this will be like this, and at each step I have two lists, up and down. What do I do? If down is empty, then there is nothing to do anymore. I don't have to create any new elements. If no down, then nothing else. Wondering if this pattern has a name. Okay, else let's just do what? So first of all, I have to create an element which will consist of up and down at this point, and oh, actually it bites me again. So case down of if it's empty, then nothing. There is nothing to do here. If it's a list of element x and some rest of down, then I just produce a tuple of x concatenated to up and down prime, the new down. Okay. So what's the error now? Should it be like this? Something is on here, but I'm not quite sure what. So couldn't match the expected type. Oh, okay, yeah, it should be just. Now it also has difficulties with what? So I have pattern 1. So the error is in the first argument of just, namely x x prepended to up and down prime. Could not imagine the expected type. Oh, right. I also have to produce some tuple, what I want to see. And yeah, that will be just up and down. Yeah, and now it type checks, and now it doesn't produce anything. Oh yes, because at the start it's always like this. And yeah, now I get all of the reflection, all of the possible horizontal lines. And I have a nice zipper that goes through every possible combination. Okay, I'm back. Okay, now let's write this down. All reflections yeah, let's say reflections zipper. Reflections zipper. So let's take the input and let's say that it is a folder of part up and part down. Case down of this is nothing, and x and down just up down, x up down, and all of this is applied to the input, but I can actually make it a little bit shorter because it's really gets too long. Let's just write the type to make the life easier, and it basically takes a list of char and returns a list of char, or even better, string. Yeah, let's replace that with just a string, and it just gets all of the possible reflections. Okay, a reflections zipper of the input, and what does it do? For each of the reflections, it tries to determine if this is a reflection. And I can also give that indexes. Yeah, let's call this isReflection. It takes two parts, up and down, and it can say that case up down of if any of them is nothing, then no, this is not a reflection. If there is an up and down element as well, then if u is equal to down, in this case we just proceed with isReflection of the next is the pair of the tails a reflection as well. Okay. And it also Okay. Actually, I could do that better. So if any of up and down is empty, then it should be nothing. Otherwise, if they are not empty, I can just try to zip with equal up down, and then I can just ask the end of this. But this should only work in case where they are both not empty. Okay. I think I should make this into a top level function. String, and it produces a boolean. Just int, actually, the length of the upper part. If, and this can actually be written like this. Zip with equal if and then I return just the length of up, else nothing. Let's reload. What's one now? Oh, okay. Yeah, that's a lot of characters for this. reflectionsZipper. And here, let's say undefined. Yep. It's still an error. Why? Oh, yes, because of this curly. Okay, now just yeah, that must be maybe reload. There is still a type error, which is not match the expected type. Oh, yes. reflectionsZipper. So I get this pattern, and I also have to start with it. Now what? At line 15. What's wrong with you? What's the type of X? Character. And that sounds very, very wrong. Oh, yes, I agree. That should be like this, and this should be like this. Yeah. Let's reload. Let's ask. Let's reparse the input. Let's split it into pattern 1 and pattern 2 immediately. And let's ask that is if is reflection. If I take pattern 1 and an empty thing. Couldn't match type character with character. So part 1 is this. Oh yes. This is not even funny. Yeah. Variable, yeah. It's not in scope. Yeah, it's not exactly a reflection. So what do I do next? When I get the reflection zipper, I can map isReflection with it, and I can actually do map maybe, and then I can get the sum. Variable not in scope again, but maybe. Yep. Let's try that. So let's reparse and let's find reflections in pattern 1. It's empty. In pattern 2 it's also empty. Interesting. Okay. So let's lift that up and let's remove that. So what is wrong? So let's reload. Let's split into patterns. Let's get the reflections zipper from pattern 1 and let's map m. Print, for example. Is the reflections zipper empty? Why? Really, I should have just import a split. Yeah, I don't really have time for this. Build depends on split. I import data list split as well. Let's reload. Yeah, let's restart. Okay, let's ask if I have split on. What's split when? Yeah, I would just say let's split when null. And yeah, I don't have time for this. So the pattern 1. Oh, yes. It's not about parsing, it's about yeah, pattern 1, reflections zipper pattern 1, it's empty. So let's see why. Let's bring in debug trace as usual. Let's do qualified here. Let's say debug show a debug x is equal to trace show xx, and this comes from here. Okay, now debug down. What? Yeah, that's not how it should work. That's not how it should work. Oh, debug up. Okay. Oh yes, the same mistake again. I should start with an empty up and with pattern at, on downwards. Okay, reflections zipper. Now it's I don't really understand anymore what is the result and what is the debug output. How is it? Oh, okay. Okay, sounds about right. Find reflections in pattern 1. I get nothing. In pattern 2, I get 1 at 4. Okay. So, and if I ask what do I get from transpose, I get my 5. Okay, it works. Oh, finally. Yeah, so now I can solve it. I should get 4 or 5, so I have to multiply sum of find reflections in a pattern plus sum of find reflections in a transposed pattern. Okay, where the pattern comes from. Map. And then I have to sum all of this. Yes, since it's linear, it should not be a problem. Okay. So in this case, what is the return type of this? Let's just look at the error. What does it tell us? Oh, okay, yeah, I agree. So, let's input. Let's parse it. I have my input. Let's solve on the input, and I get 4 or 5. Sounds good. So if I stack run the example txt, I should get 4 or 5. Then when I get it on the input, do I not have my input in here? Oh, okay, yeah, it's just input. And that is something plausible. Yes, that's the right answer.